You are moving round the sun at about 30 kilometers a second, right now, and you cannot feel a thing. In fact, you have never felt speed in your life. Not once. A body cannot measure it. What you can feel is speed changing. Stand in a lift, and you get 3 different feelings in one short ride. The moment it sets off upwards, the floor pushes harder on your feet, and you go heavy. Then in the middle, nothing at all. And that is the strange one, because the middle is where the lift is moving fastest. Then near the top, as it eases off, you go light for a second. Heavy, nothing, light. One ride, and the fastest moment of it is the one you cannot feel at all. So the quantity your body is actually measuring is not the speed. It is the rate at which the speed is changing. Differentiate the height, and you get the speed. Now differentiate the speed. The derivative of a derivative. That is the second derivative, and it is the whole of this lesson. By the end, you will be able to look at any curve and read its second derivative straight off the shape, with nothing calculated. And it is the same reading whether the curve is a journey or just a graph on a page. So take one journey and draw it properly. A lift leaves the ground floor, rises 48 meters and stops. The whole trip takes 12 seconds. The top graph is its height above the ground, against time. Flat at the start, steep in the middle, flat again at the top. Flat at both ends, because it is standing still at both ends. The middle graph holds the slope of the graph above it, at every moment. That slope is the lift's speed. So where the top graph is flat, the middle one sits at 0. Where the top graph is steepest, the middle one is at its peak. 6 meters a second, exactly halfway up, 6 seconds in and 24 meters off the ground. And the bottom graph holds the slope of the middle one. That is the acceleration, and it is the thing you can feel. At the start it reads plus 2 meters per second. That is the push in your feet. At 6 seconds it is exactly 0. That is the nothing in the middle, and it lands on the fastest moment of the ride. At 12 seconds it is -2. That is the lift easing off and the light feeling. 2 meters per second is about a fifth of gravity. So at the moment it sets off you really do weigh about a fifth more. Every feature of the top graph is a fact about the bottom one. It is one journey, read 3 ways. Here is that lift as a formula. The height in meters, after t seconds, is t squared minus t cubed over 18. Check the ends. Put in 12 and you get 144 minus 96, which is 48. The lift arrives. Differentiate once with the power rule from lesson 4. Bring the power down, drop it by 1. 2t minus t squared over 6. That is the speed, and it is the middle graph written down. Put 6 seconds in. 12 minus 6 is 6 meters a second, which is exactly the peak we read off the picture. Now the one new move in this video. Differentiate that answer again by the same rule. 2 minus t over 3. A straight line, and that is the bottom graph. At 0 seconds it is 2, at 6 it is 0, at 12 it is -2. Heavy, nothing, light in order, out of the algebra. On the page it gets 2 names, and you will meet both. The first is the function's own name with 2 dashes after it, f double dash of x. The second is written like a fraction, with a 2 on the top and a 2 on the bottom. You say it as the second derivative of y with respect to x. That 2 is not a power. Nothing is being squared. It is a tally of how many times you have differentiated. The recipe really is that short. Differentiate, then differentiate the answer. Now do something small. Take the word time off the bottom axis and leave the 3 graphs exactly where they are. The graphs do not care. The middle one is still the slope of the top one. The bottom one is still the slope of the middle one. So what is that bottom graph telling you now, when there is no journey and nothing is moving? Here is a curve to ask it about, x cubed minus 3x. Its slope function is 3x squared minus 3. Differentiate again, and the second derivative is 6x, a straight line through the middle. Look at the left of the picture, where 6x is negative. On that side the curve bends downwards. It rises, rolls over a hilltop and comes down. Run a finger along it and the finger keeps turning clockwise. Now the right, where 6x is positive. The curve bends upwards, like the inside of a valley, and the finger turns the other way. Both shapes are worth naming because exam questions use the words. Bending upwards is concave up. Bending downwards is concave down. So the second derivative is the bend. Positive bends up, negative bends down, and the size of it says how fast the slope itself is changing. Far to the left, 6x is a big negative number, and the slope there is dropping fast as you move along. Near the middle it is nearly 0, and for a moment the curve is not bending at all. And this is not a second meaning bolted onto the first. It is the same reading. A graph is a picture of a journey. The push you feel in a lift and the bend you see in a curve are one number wearing different clothes. The slope and the bend are independent. All four combinations happen, and mixing them up is where most of the marks in this topic go. Rising and bending up, going up and getting steeper as it goes. That is the runaway one. Falling and bending down, going down and getting steeper on the way down. Falling and bending up, still going down but the fall is easing off. And then the one that costs the marks. Rising and bending down, still going up but less and less steeply. Bending down does not mean coming down. The curve in that fourth picture never goes down once. You have heard exactly this confusion on the news. When inflation falls, prices do not fall. Prices are still going up. What is going down is the rate at which they are going up. The price graph is rising, so the first derivative is positive. It is bending down, so the second derivative is negative. Case 4. Falling inflation is a sentence about a second derivative, which is precisely why it never sounds like good news in a shop. The lift does the same thing after 6 seconds. It is still going up, the whole way to the top. It is just going up less quickly. So what is it for? First, it gives you the shape of a graph without plotting a single point. The slope says which way it is going. The bend says how. Second, and this is the one the exam wants, it tells you what kind of turning point you are standing on. At a turning point the slope is 0, so the curve is flat, and the bend is the only thing left that can say which way it is flat. Bending down at a flat point, and you are on a hilltop. Bending up at a flat point, and you are at the bottom of a valley. That test is the whole of the next lesson, so we will do it properly there. Here, just watch it work. Take x cubed minus 3x again. Its slope function is 0 at -1 and at +1, 2 flat points. The second derivative is 6x at -1, that is -6. Negative, bending down, so that flat point is a hilltop. At +1 it is +6. Positive, bending up, so that 1 is the bottom of a valley. 2 lines of working, no sketch, no table of values, and the picture agrees. 2 traps to take away. The first is that little 2. It counts, it does not square. F double dash of x is not f of x squared. The second is subtler. A second derivative of 0 does not on its own mean the bend changes there. It usually does, it does not have to, and that trap has a lesson to itself 2 videos from now. Differentiate once for how fast something is changing. Differentiate twice for how that rate is itself changing. One of them is the speed. The other one is the thing you can feel.